All right. So this presentation pertains specifically to wax. Very exciting, I know. Um, so Basically, what I'm going to walk through is kind of what is wax, historical purposes of it, and what it's used for today. The different types of wax, its relationship with adhering to fabric, and then kind of talking about how to remove it from fabric. So, wax is a pliable substance from a plant. It can be from an animal, it can be synthetic. For example, an animal would be beeswax. So, it's different from fats because they feel less greasy. They're not actually greasy, but they have like a little bit of a greasy feel to them. But less so than fat. They're harder and they're much more brittle. It contains compounds of high molecular weight. They melt at a moderate temperature, somewhere between 95 degrees Fahrenheit and 212 degrees Fahrenheit. It depends on the block of wax, truthfully. And it's excellent for waterproofing. So some examples of this might be, I know that LL Bean, Snow Seal, and Hogs offer waterproofing wax, which you can put on boots. So that helps with like winter or rain, helps protect them from getting water damage. Also, I've seen people put wax in like backpacks and heat it with like a hair dryer and melt it on to help make their backpacks a little bit more waterproof. Not exactly how well that works, or not exactly sure how well that works, but I've seen people do it. So definitely an excellent tool to use for waterproofing. All right. And so some of the historical purposes include, well, basically wax has been around since the Egyptians. Back in 3000 BC, it was noted that they had used wax for candles, and it's likely that it has been used previous to that, but it's kind of the first time that um, people from nowadays, that's as far back they can see wax being used. So it's used for many, many things, including crayons and food and polish and candles. But some of the unique properties of wax include how it's used for packaging. And so the reason why people use it for packaging is because it's an excellent barrier for acting for it's excellent for acting as a moisture barrier. It since it's so water resistant, it's really helpful with keeping foods dry inside their packages. It's also an excellent insulator. So usually paraffin is the wax that's used for this, and it's due to the fact that it has a long carbon and hydrogen chain of atoms. So they're very unlikely to carry an electrical charge. This is because both ends are inactive and do not have positive or a negatively do not have positive or negatively charged atoms. So the absence of free ions causes the wax to be unable to conduct electricity. So that makes it a really safe choice for that job specifically. It's also used for ink or in ink because it provides rub resistance so your ink doesn't spread all over the place. And then it's also used in cosmetics, mainly because it helps boost viscosity and creates a more stable product. So beeswax. Beeswax has a few notable physical properties. It can be soft to brittle depending on what state it's in. Its melting point is roughly 60 degrees Celsius, but honestly, it can be a little bit above, a little bit below, but somewhere within that range. Heating, it causes the physical properties to change. Shrinkage occurs when it's cooling. It can sometimes take on a plastic type of, kind of like a plasticky type of bendability. I'm trying to think the right word, but bendability is maybe the right one. But sometimes it can become also really, really stiff. Um, it consists of 284 compounds, which are long chains of alkanes, acids, and ester. Um, hentricon- Hentricontane comprises 8 to 9% of beeswax and is responsible for the stability and impermeability of water. Beeswax specifically is used for various beauty products, including lip balm, hair product, moisturizer, and several different types of makeup. Paraffin wax, on the other hand, is made of petroleum, coal, or shale oil. It is soft and colorless with a melting point around 50 degrees Celsius to 62 degrees Celsius, relatively similar to beeswax. It is made up of alkanes, um, and they are nonpolar and insoluble in water. And they're typically used for waterproofing wood and cork, possibly coating food containers and covering food wrappers. So wax on fabric, beeswax and paraffin are mixed together when they're used in the art of batik. That is because beeswax adheres well to the fabric and is much less brittle than paraffin is. But paraffin needs to get mixed in because paraffin makes it a lot easier to remove that wax. I've already conducted my experiments where when I put on 100% beeswax and 100% paraffin on a cotton sheet, and the paraffin came off in a snap. I boiled that fabric for a few minutes and the beeswax still wouldn't come off. So it's necessary to have the two mixed together just for like patience wise. You need that wax to come off eventually in order to continue on working with your work on your product. And so over time, people have developed like unique combinations and ratios for the different types of waxes. I used a 50-50 mix. It didn't work super awesome. It wasn't the best mix. If I could redo it, I'd probably use a little bit more beeswax. I was actually reading an article today, and it seems like a lot of people like the 75-25 mix, 75% beeswax, 25% paraffin wax. But people just come up with their own mixtures, and they kind of do whatever is the most effective for them and achieve the goals that they want. So that's kind of the relationship between the two. So the chemical structure of wax. Paraffins are alkanes, which means that they are made solely up of carbon chains. They're completely nonpolar, and since they're completely nonpolar because they have a very low electronegativity. And beeswax is made up of compounds from three functional groups. It's a key difference. And those three functional groups are ester, alcohol, and carboxylic acid. I'm learning how to pronounce these words. And so all three of these are polar, which means that they're soluble in water and other polar solvents. And that especially the acid is polar. But yeah. So the chemical structure of cotton. So cotton is a 5-carbon, 1-oxygen ring. It has a nonpolar backbone with polar functional groups covalently bonded to that backbone. And beeswax sticks much better to the cotton since they have similar functional groups. Adhesion. So this is pretty key. So the reason why I'm bringing up adhesion in this presentation is because the only way that the wax sticks to the fabric is because of adhesion. So I was curious, how does that even happen? Like in daily life, you see these things happen, you kind of accept it, but when you really think about it, why is it sticking to this other fabric? What is it that they have in common that allows them to remain together like that? And so what I found was that cotton is basically just cellulose. And it's attracted to beeswax since they have those similar functional groups. So cellulose is a 6-atom ring of 5 carbon and 1 oxygen on each of the atoms in the backbone. And in the backbone has OH. Beeswax is made up of a variety of compounds containing 3 main functional groups, which are alcohols, which are OH, esters, which are COC, and carboxylic acid, which is COOH. Carboxylic acid is very polar and esters are slightly polar. Paraffins have a weak interactions with the cotton since cotton is more polar than the paraffins. So that is why beeswax does a better job of sticking to the fabric as opposed to paraffins, because paraffins doesn't have those functional groups. But that's why you need a combination. That's why you can't just use paraffin. You can't just use paraffin when putting wax on fabric. And so when it comes to the removal of the wax, the way that you do it in the craft is you basically boil the fabric in hot water and then let it sit there until the wax melts off and you take it out. Now, the reason why that happens is because heating the cloth causes the wax to melt. And when it's immersed in the hot water, the bonds break and the wax comes off of the cloth. And if you see the chart on the right, it shows that when heat goes in, it causes bonds to break. And when those bonds break, they release, and therefore the wax releases itself from the cotton fabric. I believe that's my last slide. So that's kind of an overview of why the wax sticks to the fabric. And that's the reason the kind of offers a little bit more light as to why beeswax and paraffin need to be in combination with one another, especially a more heavy beeswax percentage than of paraffin. Yeah, so I think that's it for this presentation.